Hello everybody, welcome back to From Rhythm to Algorithm Part 65, Chirality. I haven't made a formal math video in a little bit, again just because gotta just solve all science, gonna take a minute to solve all science again. But we're gonna discuss chirality, symmetry, asymmetry, our functional definitions, and I discovered, literally about an hour ago, I discovered a very interesting geometric proof for geometric linguistics. So first, what is chirality? If we was up in the clubs and you spontaneously asked me what's my functional definition right now of chirality, just meaning what word would I blurt out after that? I would say non-superimposability with a flip or rotation. Just meaning non-superimposability, right? Another definition, chirality does not cover, map, regardless of change. So meaning, right, the very common example, if you take your left hand and you flip it or you rotate it in any way, and then you try to put it back on the original image of your left hand, it will not cover the image of your hand. And so, typically, I mean, that type of definition goes to self-asymmetry, right? You're talking about the base, the original left hand positioning versus some sort of rotation or flip change. And so, where the proof is really going to be, we're going to ask the question, are the letters Y and the letters H chiral? And so, I just want to read a little bit about from the Wikipedia. I was reading something. It says, in mathematics, so let's get to the geometry part. In geometry, a figure is achiral if, and only if, its symmetry group contains at least one orientation reversing isometry. In two dimensions, every figure that possesses an axis of symmetry is achiral, and it can be shown that every bounded achiral figure must have an axis of symmetry. In three dimensions, every figure that possesses a plane of symmetry or a center of symmetry is achiral. There are, however, achiral figures lacking both plane and center of symmetry. In terms of point groups, all chiral figures an important axis of rotation. All chiral figures lack an improper axis of rotation. This means that they cannot contain a center of inversion, I, or a mirror plane. I forget the Greek letter. Only figures with a point, group designation, blah, 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 blah. Now forget all the formal math shit. The stuff I want to get out of here is, again, can I rotate? And first of all, is there any other types of rotations? Can I do anything else to these letters? I have just a cardboard H and a cardboard Y cut out. I can flip it, right? If you go take a picture in a mirror, flexing your abs, you have a tattoo on your right arm, and it shows up on your left arm, that's a flip rotation or a flip change. So we're expanding the definition to say regardless of change. Is there anything I can do to these letters to make them, make them map each other, cover each other physically, right? There's basically a couple approaches I can do. I can have H and Y, both again, be specific to geometric linguistics. I was gonna do this as a short, but I just want to do more explanation. But obviously, I don't say obviously, but the capital H and capital Y, the geometries are not similar enough to even have potential to cover each other. So they would be chiral, right? They are not symmetric. There's nothing you can do to one another to have the capital H and capital Y written in standard notation, like just sort of the way people write the letter and have them cover one another. So I just have the lowercase letters, and so I can have the H, I'll just leave H the same, and again, chirality as is defined is typically, the base to itself, the left hand to the left hand, but are these two letters mappable? Do they cover each other in any way? So I can take the H, I can rotate it 90 degrees, definitely not. I can rotate it 180 degrees. You might say it looks kind of like that, but again, no, definitely not. But it is symmetric to the Cyrillic letter, like share, show, sha, one of those ones. So then I can rotate it another 90 degrees, obviously not. I can rotate it another back 360 back to its starting position, obviously not. So I can do the same thing, it's equivalent, but rotate the Y instead, just going through exhaustive, all the options. 180 would be closest, but obviously not. And then boom. So then I can flip the H, and I can try to cover over the Y, nope. I'm trying to keep the orientation as you would have written it down, but nope, nope, definitely not, definitely not, definitely not. So then I can do the same thing, keep the H the same, flip the Y, boom, boom, definitely not, definitely not, definitely not. This looks like lambda from Greco. 270, definitely not. 3/4 pi, think, no. Fuck, I'm fucking up my unit circle, sorry guys. And then 360, not. Then to begin exhaustive, flip them both. Can you superimpose them in any way? Nope, that would be the closest, but clearly not. And then the rotations are redundant. So, no. We have just geometrically proved that H and Y are chiral, right? There's no change we can do to have these numbers map one another. Nothing. False. Fake news. Proof of geometric linguistics. Regardless of change, I want you to write in cursive an H. Now I want you to write a Y. Now rotate those bad boys 180 degrees. Seriously, do it on a piece of paper and just rotate it. The H's will become Y's and the Y's will become H's. So are Y and H chiral? No, not in cursive. So I don't know. That was an interesting geometric proof I definitely discovered like an hour ago. I was pretty excited about it. So I think I delivered it pretty well. So thank you for watching From Rhythm to Algorithm, part 65, Chirality. Now, we generalize the result. And somehow, guess what, how you spell rhythm? R-H-Y-T-H-M. So now, and that is like the base vowel, sometimes Y in rhythm. So now, can we make some sort of generalized statement about chirality and iteration of letters or something? I don't know. That was a big result for me. I was pretty excited about it. So, hope you learned something, and thank you for watching From Rhythm to Algorithm, part 65, Chirality.